Hello guys, welcome back to the channel in the series of data science. We are currently discussing the 10th lecture which is dimension reduction. In this we are discussing two methods. We'll demonstrate how you will identify multicollinearity in Python and how you will demonstrate principal components analysis which is PCA. So first, identifying multicollinearity in Python. Multicollinearity refers to the situation in regression analysis where two or more predictor variables are highly correlated with each other. This can cause instability in coefficient estimates, making it difficult to assess the individual effect of each predictor on the dependent variable. To address multicollinearity, identifying and managing it is essential. Now, let's see the methods for identifying multicollinearity. There are two methods as you can see. Correlation matrix, first one is one way to detect multicollinearity is by computing the correlation matrix between the predictor variable, a high correlation close to +1 or -1, which indicates potential. And the second is variance inflation factor, which is also commonly known as VIF. VIF quantifies how much the variance of a regression coefficient is inflated due to collinearity with other predictors. A VIF value higher than 10 suggests a problem with multicollinearity, indicating that a variable is highly correlated with others. It means if a variable is having 10 or more VIFs, so it is not good for our data. It is highly correlated with others, and changing in other data will result in the changing of that element too, or vice versa. So, these methods help identify whether multicollinearity is present and allow you to take appropriate steps, such as removing or combining correlated features. Now, this is the code for multicollinearity. First, we are importing libraries, Panda, and all the functions, load iris, standard scalar, variance inflation factor, and add constant. Now here we are loading the data set. Data is equal to load iris. Then we are creating a data frame, which is known, which we are giving name as df is equal to. Then this is the syntax for creating the data frame. Now let's calculate the correlation matrix. So this is the syntax correlation underscore matrix of data we want to correlate metric is present in df. So we'll create df dot corr. This is the syntax for it. Then just print the correlation matrix. Now standardize the data set. Scalar is equal to standard scalar. Then we are transforming the data, and here x is the constant, so add constant for VIF calculation. Now calculating VIF, we have to give this, we have to write this line. This is the syntax for calculating VIF. Now just print the VIF. Now talking about PCA, which is principal component analysis, it is a powerful technique used for dimensionality reduction in data science and machine learning. It transforms high dimensional data into a lower dimensional form while retaining the maximum amount of variance possible. PCA is useful when you have a large number of features but want to reduce the complexity of the model without losing significant information. This is the important line which says that we don't want to reduce the complexity of the model, but there is also a large number of features. So we use this. So steps involved in PCA. PCA is a pretty complex method, so it has many steps. The first one is standardization. PCA is sensitive to the scale of data, so it's important to standardize the features before applying PCA. Standardization transforms the data into a common scale, ensuring that all features contribute equally to the analysis. Decomposing the data. PCA involves finding the eigenvectors and eigenvalues of the data covariance matrix. These eigenvectors represent the principal components. Third is choosing principal components, which is the most important step. After applying PCA, you can decide how many principal components to keep based on the explained variance ratio. This tells you how much of the original data's variability is captured by each principal component. Visualizing the result. Once you have reduced the dimension, you can visualize the data in 2D or 3D plots for better understanding of patterns and structure of the data. PCA is often used for exploratory data analysis, noise reduction, and preparing the data for further machine learning tasks. This is the code for PCA as same. First, we are importing the libraries and functions PD, PCA, standard scalar, MATLAB, मैटप्लॉटलिब से PLT किए, sklearn से लोड iris किए, फिर डाटा को डाटा फ्रेम में डालें. um, then scalar is equal to standard scalar, standardizing the data. Then apply PCA to reduce two components. Here, see the syntax of PCA, which is PCA is equal to PCA n components. We want to do for two components, or is it we are writing two. If we want to do for three, then we'll write three. पीसी अंडर स्कोर रिजल्ट में अपन डाटा डाल देंगे. पीसीए अंडर स्कोर डीएफ इज इक्वल टू पीडी डॉट डाटा फ्रेम पीसीए रिजल्ट कॉलम पीसी1 पीसी2. नाउ प्लॉट द पीसीए रिजल्ट. सो एक्स में डाल दिए पीसी1, वाई में पीसी2, एंड द टाइटल ऑफ दैट प्लॉट इज पीसीए 2D projection. Now by using plt.show, which is used to show the plot, will be showing the plot. This is all for today's lecture. Thank you.